Hello everyone, and welcome to another episode of TD 101. In this episode, you will be shown how to construct different regular polygons using one simple formula. Stay tuned. Okay, so in this exercise, I am going to construct a regular heptagon. The heptagon consists of 7 sides, right? So I'm going to use the formula, and please bear in mind, this method that I'm using is applicable to construct different types of regular polygons. So it's not limited to the heptagon. When I constructed the pentagon in a previous video, I also used this formula. And the video that I'm referring to is the video where I constructed a pentagon given the length of one side. So once you're given the length of one side of the polygon, you are able to use this formula. So let me draw my baseline. And the length that I'm going to use is 50 millimeters. So from A to B, 50 millimeters. So that's the length of one side of the heptagon. Now I'm going to take my 60-degree set square, and please note how I'm positioning the set square. I'm positioning it in such a way that the 60 millimeter side is the angle 60 millimeters. I'm also positioning it in a way that from A, you get a 60-degree angle. You can erase the extension of the construction line. I'm also going to take my 45-degree set square and do the same thing. I'm going to call this point 4. I'm going to call this point 6. Then I'm going to take the set square and connect point 4 to point 6. After doing so, I'm going to bisect the line that is formed at between points 4 and 6. Line 4, 6. So I'm going to open the compass to more than half the length of the line. Put it at 4. Swing arcs on each side of the line. Also, without shifting the compass, place it at point 6. Swing an arc on each side, cutting the 2 arcs that I've drawn previously. I'm going to now use my T-square to draw a line through both arc intersections. That will give me a point 5 right here. Alright, this point was used as the center of the circle that was used to draw the pentagon. And that circle was a circle that was circumscribed around the pentagon. And by now you should know what a circumscribed circle is. Now I'm going to extend this line and basically open the compass from 4 to 5 and cut from 6. So I'm opening the compass this distance, which is the same as this distance, and I'm swinging arcs going up. So basically, this is 0.7, this is 0.8, this is 0.9. You can continue 10, 11, 12, etc. Now, If I want to draw a septagon, I'll use 0.7 as the center of the circumscribed circle. If I want to draw an octagon, I am going to use 0.8 as the center. And you get the picture. If I want to draw an hexagon, I use 0.6. If I want to draw a pentagon, I use 0.5. If you want to even draw a square, you use 0.4. Because a square is a regular polygon. Alright, so let's put the compass point at 0.7. And the circle that you're going to draw should pass through points A and B. So I'm going to open the compass from point 7 to point A. And it should also pass through point B. Right? So I'm swinging. So this is the circle. Then I'm going to open the compass at a distance equivalent to the length of one of the sides, which we know that it's 50 millimeters. So from point B, I'm going to swing an arc to cut the circle, and from point A, I'm also going to swing an arc to cut the circle, with the radius of the compass set to 50 millimeters. So this is point C, D, E, F, G. So this is point G. Then from C, I'm going to swing an arc, cutting the circle. From G, I'm going to do the same thing. So this is point D. Then this is point F. Then I'm going to swing. There are multiple ways to do this. I can either extend the line, given the fact that it's a polygon that consists of an uneven number of sides, meaning 7 is an uneven number. So you can do that to get the point. Or if it's an hexagon, you open your compass using the same radius. Continuing, right? If this was an octagon, you would have to open the compass and swing for the other 2 points, right? And there's something that you can use to determine if your drawing is correct. If you open the compass from D, it should cut that point that I'm referring to here. If you open it from F, it should cut the point because it should have shown that your drawing is correct. So let's brighten the points. All right, and this is the heptagon. So AB is equal to 50 millimeters. And there you have it. This was constructing a regular polygon given the length of one side. Now this can be applied to all of the polygons, whether it's a 4-sided, 5-sided, 6-sided, 7-sided, 8-sided, 9-sided figure. Can also be applied to a 10-sided figure, 11-sided figure, etc. Please remember to like, share, and subscribe for more content, and have a good day.